Good morning. I am Lakshmi, Assistant Professor, Department of AADS, SRM Engineering College. Today I am going to brief you about the ensemble techniques as well as unsupervised learning. To begin with, we'll start with what is meant by combining multiple learners. Model combination or ensemble learning is nothing but a strategy where you are going to combine different machine learning models which is going to help you to solve the problem and improve your performance. The main aim or the goal for going in for ensemble learning is to get a better accuracy as well as to achieve a better generalization than a single model. So why we have to combine model? The main reason is that it reduces overfitting, reduces underfitting, and it tries to improve the accuracy of the model. So ensemble techniques, to begin with, let us see a brief idea of what an ensemble technique is. It is a powerful technique which is where multiple models are going to be combined to improve the overall performance of the system, which is going to be mainly used for prediction purpose. The fundamental idea is nothing but aggregating or combining the predictions from diverse models, thereby reducing the weaknesses and trying to improve the model in a better way so that it is more accurate and you get a more reliable result. Ensemble methods are techniques which is used for improving the accuracy of the results. So the combining the model, the main purpose is to improve the performance as well as the accuracy. So each model can be a different classifier. You can have a KNN, you can have a decision tree, you can have a logistic regression, and you can use any one of the NSML methods that has been listed to combine all these models. The different NSML methods that are available are voting, boosting, bagging, as well as stacking. So NSML models are mainly suitable for regression as well as for the purpose of classification. So here this diagram shows you where you give an input training data. It is given to different model. Each model can be a different classifier. It can be an LR logistic regression. It can be a KNN. Each model will give its prediction. Then the predictions that is got from different models are being combined using the NSML meta model, which is going to give me the NSML predictions. So each classifier will help me to classify and find a different set of data group, and by using the ensemble techniques I combine it to achieve a better accuracy. So ensemble technique, learning or technique, the main categories of it is bagging, boosting as well as stacking. Let us see each one in detail. So common ensemble techniques, to begin with, the first one is voting. So it is, as the name indicates, here you are going to make the final predictions based on the majority of the vote that has been given. So it is mainly used for classification, and sometimes you take the average values where you'll be using it for regression. So it combines multiple individual classifiers or regressors to make the predictions. So there are two types of voting. One is hard voting and soft voting. In case of hard voting, the majority class is going to win, whereas soft voting uses predicted probability and it will choose the class which is going to have the highest average value. So for example, they have given three classifiers, classifier 1, 2 and 3. First one is dog, second one is cat, third one is dog. So in case of hard voting, the dog is going to be win because you have two times the dog has appeared out of the three classification. So in case of hard voting, the majority vote is selected as the final prediction. In case of my soft voting, it is going to be the weighted average of the predicted probabilities that is used to make my final predictions. And mainly it is suitable whenever you want to have a probability estimates where you try to take the sum of the predicted probabilities and you predict the class that is going to have the highest sum. And here the classifier variants will be voting classifier will be there, voting regressor will be there. Voting classifier will combine multiple classifiers for classification tasks. Voting regressor will combine multiple regressor for the regression task. And here the base model that has been commonly used will be SVM, that is your support vector machine, LR logistic regression, and DT, which is nothing but my decision tree. So hard voting, again I have three different models. I'll be combining using the ensemble techniques, and depending upon the majority, I will be going in for the predictions. So in case of my soft voting, the document will be given to three different classifiers. So it will predict the probability whether it belongs to class A or class B. And depending upon the predicted values, whichever I combine all these values and try to identify, or I try to classify the system that is being given. So depending upon the probability values, I go in for soft voting, and depending upon the majority voting, I go in for hard voting. So hard voting, in case of hard voting, each classifier will use the ensemble to predict the class model. So previously we saw the dog example. So if there are three classifiers in case of hard voting, the prediction classifier will go for dog as it is appearing two times out of three occurrences. So it is mainly used when you have output labels which are given directly to the classifiers. And soft voting, purely it is going to be based on the probabilities. So here we have having three classifiers. Each classifier is classifying the given system into two classes, class 0 and class 1, where the probabilities are given. So for classifier 1, the probability is 0.2 for class 1 and 0.8 for uh, class 2. For classifier 2, it is going to be 0.3 for class 1 and 0.7 for class 2. For classifier 3, it is 0.1 for class 1 and 0.9 for class 2. So average of the probabilities will be taken, and depending upon the average that is being got for class 1 and class 2, the final prediction will be made. So this will be for your soft voting. And the main difference between hard voting and soft voting is that hard voting takes class labels as input, whereas soft voting takes the probability estimates. And when it comes to decision, hard voting makes based upon the majority, and soft voting does it based upon the weighted average of the probabilities. Next comes the second technique, which is called as bagging. You can also call it as bootstrap aggregating, and mainly it is used in classification and regression. So here you try to train independent model on different random subsets of data that has been available, and then you combine the predictions. So predictions can be combined based on voting or averaging. And the main benefit of bagging is that it reduces variance and makes the model little more stable. So common algorithm that will be used for bagging will be random forest, which is going to be combination of bagging technique as well as your decision trees. But the disadvantage is that it is computationally expensive. And bagging is nothing but a technique which is mainly used for creating multiple versions of the model, where you try to combine the output only to improve the overall performance. And going in for bootstrapping, bootstrapping is nothing but a technique where samples are going to be drawn with replacement, and the final predictions will be made either based on the averaging the predictions or by majority voting that is being done. So steps in bagging is nothing but I create multiple subsets from the original data set. Then a base model will be created on each subset. The model is going to be learned in parallel with the training set, and the final predictions are going to be determined by combining the predictions of all the models. So this is what is bagging is, bootstrapping and then aggregating, combining it. You get the value for your bagging from the original data. The common algorithms that will be used for bagging will be random forest, and you can make use of decision trees. So random forest is one of the ensemble methods which is based on decision trees, where multiple decision trees are trained, and you combine the values. So this is mainly used to introduce randomness by selecting a random subset of feature, and it mainly reduces the variance and overfitting. In case of decision trees, you find multiple decision trees are trained using bootstrap samples of the data, and each of the train is trained separately to make a final prediction, and then we average it to get the final value. So boosting is nothing but a sequential learning training technique where learners are trained one after another. It is mainly used for fixing the errors, and the final model is based on the weighted combination of all the learners. The advantage of it is that it reduces bias, and the result is a very accurate one. So this we have already seen. General information about boosting is over. So now we'll move on to how the boosting process actually work. In case of boosting, you divide the original data into number of subsets. Each of the subsets is given a training. You try to identify the weak learner which makes you the false prediction, correct it by giving it as an input to the next subset, and you repeat the process until the overall prediction is going to be made. So common algorithms that will be used will be ADA boost, gradient boosting, and XG boost. Few of the algorithms which can be used for boosting is nothing but ADA burst. It works by adjusting the weights of the misclassified instance and then combining the predictions of the weak learners. In case of gradient boosting, it is a more general approach that can be used for boosting that helps you to build a model in a more sequential manner. XG boost, which is nothing but extreme gradient boosting, it is considered to be an optimized version of the gradient boosting algorithm, and commonly it is the most popular choice because it gives a high performance. It is the common one that will be preferred for all machine learning operations. So here we have just shown a picture of how bagging and boosting works. Bagging is done in parallel, whereas boosting is going to be done in a sequential manner. So the main difference between bagging and boosting, here it aims to decrease variance, boosting aims to decrease the bias. Here each model, in case of bagging, each model will receive equal weight. In boosting, all the models are weighed according to their performance. And this is bagging is the simplest way of combining the predictions that belong to a same type, whereas boosting is a way of combining predictions that belong to a different type. The best example for bagging will be random forest, and in case of boosting, it is going to be the ADA boosting technique that will be used. So coming to the fourth type, which is nothing but stacking, we call this as stack generalization. It is again used to combine multiple models. Base models normally make the predictions, whereas the meta learners will learn how to combine these predictions because the main goal will be to improve the predictive performance. The benefit is that it can mix different model types and it captures or it is suitable for diverse patterns. The example of it will be for base learners, you can make use of SVM, KNN, and decision tree. For meta learner, you can go in for a logistic regression. So in case of stacking, it is nothing but an ensemble learning technique where the final model is known as a stack model, which combines the predictions from multiple base models. So the main idea is that you divide them into two models, base model and meta model. Base model will be level 0 and meta model is going to be level 1. Base model, it is mainly used for original training of the data, and the meta model is the final model that learns from the output of the base model rather than using the raw data. So in stacking, you have the training data set, you give it to different models. The predictions of each model is given as an input feature for the meta classifier, and the meta model will be the one that will be making the final prediction. So steps to implement stacking is that you start with the training data, then you train the base model, generate the predictions, train the meta model, and the output of the meta model is the one that is going to give you the final prediction. So the advantage of stacking is that it gives a better performance, combines different models, reduces overfitting, and learns from the mistakes that it has done. Whereas the limitation is that it is a little bit complex and it has a slow training time, and it is you have the risk of overfitting and it is hard to interpret. Next, we'll see a comparison of all the techniques that we have studied: bagging, boosting, stacking, voting, and averaging. And we have also listed the models that will be suited for each of these purpose. Hope this video would have given you a better understanding of the various ensemble techniques that is being available. Thank you.